Okay, uh, good day, everyone. Okay, this class I will introduce the section 3.1, the simple and the multiple regressions. And I will use the box office data. And the box office will be the dependent variable. Independent variable will include the word of mouth balance and the word of mouth volume and the professional critical review for the balance and the volume. Okay, let me check uh, what if the record is still going on. Okay, let's keep going. As you can see, the first we will usually ask how to compare the relative importance of the coefficients, especially when we estimate an OS regression and the dependent variable regress by x1, x2, etc. Okay, and how we use the beta comment. This one is the standard deviation. That means the variable will transform as the standardized. Okay, for example, x minus the mu and divided by standard deviation. Okay, this is the standardized coefficient effects. Okay, first of all, we will introduce the linear regression. As you can see, when you uh, loading the data and you can choose the statistic and find the linear model and related find the linear regression and click here. This screen will provide the dependent variable. You can choose the box office and another one independent variable. You may choose four variable. For example, the mouse balance, critical balance, critical volume, and word of mouse volume. Okay, you can click OK or submit. And another one, you can choose the confidence intervals or standardized beta coefficients, which means you can standardize your variables, okay, including the report coefficient or p-value, test statistic, etc. And it also shows the comment here. You can just type in the comment screen for the regression and box office and for the mouse balance, critical balance, and critical volume and water mouse volume. It can get the same purpose, get the same um, these tables. Okay, this is sum of square model and sum of square residual and sum of square total. The F value is very significant. P value is smaller, very small. And the number of observation is 568. F value is very high, 73.71. And R square is 34%. Just R square is about 34%. Okay, this one is coefficient you estimate, and the p-value here, yeah, only significant is the professional critical balance and professional critical balance. Okay, and this one is the beta. Yeah, you type here, you choose the standardized the effect, so you estimate the coefficient by the standardized, transform into the standardized. Okay. Also, we can use a comment like least coefficient, and it will generate the unstandardized and the standardized estimate. For example, the beta is the original level values, and the t statistic, this one is also p-value, is the same here, okay? And the last four column here is represent that B standardized X column gives the unit change in X expected with the one standardized deviation change in X. Yeah, here. And this one here is B standardized Y column gives the standardized deviation change in Y expected with one unit change in X. Okay, and the last one is the S standardized of X is column gives the standardized deviation of each predictor variable in the model here. Okay, so you can predict the effect directly by how many standard deviation as the effect. Okay, yeah, this one is list coefficient. Is very convenient when you compare effects. Okay, that is the 3.1. And 3.2, I will introduce the single coefficient and multi-coefficient hypothesis testing. Okay, first of all, this one is you need to regress y and x first, and then you can you can directly run the effect, run a post estimation here. Okay, so you need to regress first. Okay, when you find the statistic, you can choose the post estimation. And this one is linear test of parameter estimates. Okay, and launched. You can create the first one is the coefficient of 0. You can choose this one, and then we want to test the coefficients for the mouse balance. What if the single test, okay, single coefficient test equals to 0? It is large enough to reject the effect is different from 0, okay? Yeah, of course, you can directly type TESTWOMVA in your comment window, okay? You can just get the results here. This one is F test. Degree of freedom is 1 and 563. That's 2 degree. That's 1 degree, okay? Okay, still significant. Reject the null hypothesis. Okay, this one is substitution 1. Okay, of course, you can choose another one. And the substitution 2 both. Okay, just we can compare the CTVO and the CTVA at the same time. And this joint test different from 0. The null hypothesis is coefficients are zeros, okay? 0. So also you can just type the test TST and the CTVA, CTVO directly in the comment window, okay? You can also get the joint test. The degree of freedom is 2, and also observation is 563. Also, they are reject the null hypothesis that the effect is 0. Okay, this is 3.2, and the 3.3. In practice, I will introduce the practice and as the work in the course. Okay, so you can practice later. I assigned the null hypothesis is count positive equals to 0, a single coefficient, and another is count positive and count negative. Okay, this is the volume. word of mouth. Okay, and you can use the multiple coefficient. Use this one and test. Yeah, and later you will practice the example. Okay. Okay, and in the following, the correlation here we want to introduce. Okay, you can use the correlate comment as the shown below, or pairwise correlation. Okay, this one is approximate, handling the missing values. It can estimate the missing value by the pairwise correlation. And in a window, you can choose the statistic and the summarize table and test. And you choose the summarize descriptive statistic. Okay, and then choose the correlation and the covariance. And it pop up the display correlation matrix here. You choose the variable you want to analyze. You want to analysis box office, word of mouth, balance, volume, and the critical balance and critical volume. Okay, and you click OK, as you can see. It also pop up the comments, and you can direct type this one into the comment windows, and it also present the table here. There is a triangle, and this line in this red line is box office to box office, word of mouth balance to word of mouth. So it is one. Okay, the variable and itself, the correlation is equals to one, and this one, for example, is the word of mouth variant balance correlated with box office. If it's larger than 0.660%, we will say that it's median correlation, and if it is larger than zero point 0.8, is 80%. We will say that is highly correlated. So this one is highly correlated for the mass balance and critical balance. Okay, it's median correlation. This one is also close to the median correlation. And except these two, they are all low correlation, low correlated. Okay, we can also choose the pairwise to fix the missing value problem. Okay, so you can choose the statistic, summary, table, and test. Okay, summary and the descriptive statistic. Choose the pairwise correlation here. As you can see, you can choose here the same variables here, and click the print number of observation for each entry and the print significance level for each entry. Okay, and click OK. It will represent, yeah, here the significance and then the number of the observation for each entry. Okay, okay, print significance level for each entry. Yeah, this is pairwise correlation. Okay, of course you can practice other variables here. Yeah, this is the course work and the course practice data. Okay, so you have two works to hand up in this class. Okay, in the following sections, we examine the distribution assumptions. Usually, the classic regression assumption require the outcome that normally distributed because we need to the statistic inference, and the normal distribution is more convenient as we use the statistic inference. In a large sample, this assumption is not the importance because the central limit theorem. So if the number n sample number of sample is larger than, for example, 30, when you learn a statistic, the teachers always tell you when we need larger than 30. But practically, we need more. We need large, more, and then this one, okay? Especially for the microeconometrics. In a small sample, however, the distribution assumption can be relevant, okay? We will investigate issue concern normality. So, what do we have? The first one we can check is the histogram, and we also use the K density to approximate the distribution. First of all, we choose the graph and the histogram. Okay, for example, we can see the box office, and we choose the bin for 10 and the density, and click OK. You can see there are 10 bins here. Okay, and it is really screwed to the right. Yeah, it's very, very screwed to the right. Extremely screwed to the right. Okay, of course, the normal option to impose a normal curve. This graph is the bin 20, as we can see. If we if we cut them into from 10 bins to 20, I think it's almost the same because it's two screw to the right. Okay, as you can see, here's the grand here, and the click. You can choose up, raise the number from 10 to 20, and as you can see. Yeah. Also, we add the normal density plot. Okay, here, the green one, and it's also screwed to the right, extremely screwed to the right. Okay. Yeah. The K density here we plot have an advantage being smooth of being independent of the choice from orange, okay, unlike histogram. So we usually use implement kernel density, K density, plot here, and the command is K density, is abbreviate as K density here. Okay, we choose the graph and the smooth density and kernel density estimation here, box office, and choose the kernel function. Okay, add the normal distribution plot. Okay, as you can see, it's pretty ugly here. Yeah, it's directly line down after about one multiplied 10 power. Okay, okay, and the kernel density here, this one, red one, is normal density. So as you can see, even though you use the smoothing, it's also screwed to the right. Okay, so which means that the box office usually makes no money. Okay, but some, the number one, okay, the number one movies, for example, Top Gun, recently, and it will make huge box office. And this is the winner take all effect. The effects of winner takes all. Okay. Like many other labor economics, labor force, and always the number one have the highest wage here. Okay, here is a practice. You can check normality of the box office. Yeah, practice again. Here, the final we use the actually this one is optional. If you can use here for the analysis, which represent that you can use a screw to the right and we wanted to change it as a normal distribution. How can we do? We use the command ladder or G ladders. G ladder. Okay, ladder reports numerical results and the G ladder produce a graphic display. Okay, so how should we address this problem? For example, a distribution is not normal distribution, but we still need to regress. And the result, we wanted to suit the assumption for the normal distribution. Sometimes we will use the square term or raise the variable to the power. Okay, yeah, this is the potential transformation, like the Tyler's expansion or McLaurin transformation. Okay, let me introduce the method statistic, and you choose the distribution plot and the test. And here there is a ladder of power. Okay, chi-square, this one is cubic, square, and square root, log, inverse, square, cubic. Okay, ladder here and box office choose. As you can see, ladder, box office. This one is power 3, box office. Okay, this one is cubic, square. Okay, the level value, square root, log. Here. Okay, so if we transformed and we plot it again, for example, in the log density function, as you can see, it will, the previous graph is like this, okay? But after you choose the log transformation, the function is more like a normal distribution, okay? It needs a transform for the logarithm function. Yeah, and the ladder will tell you how to do. It will choose one. For example, the box office. Choose the log box office as the ladder transformation. Okay, this is the regression and transformation. Okay, thank you for your attention.